Hey everybody, just wanted to take a moment to show you how to use StatCrunch to answer a binomial probability question. So in this exercise, we can read that according to the airline flights, 75% of the flights are on time. So we're going to suppose that there are 17 flights. So the first part here is asking us basically to identify and to make sure that the requirements for a binomial are met. So let's just recall that the trials are independent. This is one of the required things for an experiment binomial. So the experiment performed until the desired number. This is not the case. That's a different distribution. The probability of a success remains the same. That's true. Each trial depends on the previous. That is not true. The experiment is performed a fixed number of times. That is true. There are two mutually exclusive outcomes, a success or a failure, and that is true. So we have our four requirements. So we'll check our answer and we get a nice work. So this one is asking what is the probability that exactly 10 flights are now on time? And to answer this question, you have to use that n choose x, p to the x, and then in brackets 1 minus p to the n minus x. But to help us out, let's just pull up our friend StatCrunch here. And to answer that question, if we click over here on Stat, go to Calculators, and Binomial, we get this guy right here. And let's just notice down here, we just have to fix all of this up and compute this guy right here. So let's move this down just for a second. And notice that n is the total number of trials. So n in this case is 17. Okay, and the probability of a success is 0.75, so I'll change that. And in this case, we're wanting to know what is the probability that exactly 10 flights. So this is the probability that the random variable x equals 10. Okay, and then we just click compute. So at this point in time, when you're answering the discussion board question, you just might want to copy and paste this in there. That might help out. So in this case, we get 0.0668 because I believe we have to go to four decimal places. So 0.0668. Let's plug this in. So 0.0668. Check our answer, and we are good to go. So the next component says, in 100 trials of this experiment, it is expected about blank to result in exactly 10 flights being on time. So if we did this 100 times, and if I take 100 and multiply it by its probability, then notice I take this 100, I multiply it by this probability here, and notice that I get 6.68. And it says to round to a whole number, so I'll say 7. And we'll check our answer, and we are good to go. All right, so now the next part is asking us what is the probability that fewer than 10 flights are on time. So now we come over here, and let's just note that n is still 17. Probability of its success remains the same, but we want fewer. And we have to be careful on how we read this. The probability that fewer than 10 flights. So we have to choose wisely here. So the question is do I choose less than or equal or a strict less than? And because it's saying fewer than 10, we're not going to compute the 10. So I'm going to say 0.0402. 0.0402. Check our answer. Hopefully that's right. There we go. All right, and then in 100 trials of this experiment is expected again. We take this 100, multiply it by that probability. So I'm going to get 4. Okay, click OK. So far, so good. We're doing pretty good. So now we're on part D. It says, what is the probability that at least 10 flights are on time? Well, at least 10 means 10 or more. Okay, so 10 or more. So notice these stay the same. So all I have to do is choose this, 10, that at least. So I'll go ahead and compute, and notice it says that we get 0.95 0.97, but we got a 6 there, so we know we got to round this up to 0.9598. Check our answer, and there we are. Okay, so again, we have to take this 100, multiply it by this, so I'm going to say 96. We'll check our answer, and we get an OK. And now the question is does the probability that between 8 and 10 flights, and notice this keyword inclusive, so the probability that between 8 and 10 flights, so notice I come up over here, I click between now. So the 17, the 0.75 stayed the same. So I'll change this to 8 and change this to a 10. Click compute. So we get 0.10, 0.1039. It wants us to go out to 4. So I'm going to say 0.104. 0.104. Hopefully we'll get the green box. Great. And of course we get this question again. I think we got this figured out. This should be about 10. All right. All right, so I hope that helps on how to compute these probabilities. For your discussion board on Module 3 discussion, it's probably a great idea to use this, or feel free to go to a YouTube video if you've got a TI-93 or something like that, and then you can go ahead and use that. All right? All right, so I hope this helps. Thanks. If